Continuing on, looking at rational expressions. Here we are going to multiply and divide rational expressions. We'll start out by multiplying rational numbers, just to remind you, and then look at multiplying rational expressions, then dividing rational numbers and dividing rational expressions. So when we multiply rational numbers, it's easy to think about. One way we do it is we just multiply across the numerators. So 4 times 1 goes in the numerator, 4. And then 8 times 2 is 16, goes in the denominator. And now we can notice that 4 and 16 are both divisible by 4. 4 divided by 4 is 1. 16 divided by 4 is 4. And so that would be the fraction 4/16 written in its lowest terms. Next, we're going to look at this one right here, and we have 3 over -7 times -14 over 6, multiplying across the numerators. 3 times -14 is -42. And then we have -7 times 6 is -42. And in this case, what you might notice is that we have a number divided by itself, so we know that is simply 1. And when we're thinking about multiplying rational numbers in general, we multiply across the numerator and we get a times c, and we multiply across the denominators and we get b times d. And that is how we can think about multiplying rational numbers in general. All right, for multiplying rational expressions, we do the same thing. We multiply across the numerators. 3 times -14 is -42. X times x cubed is x to the 4th. In the denominators, we have -7x squared times 9x. -7 times 9 is -63. X squared times x is x cubed. The negative divided by a negative makes this fraction positive. 42 and 63, let's see, looks like they're both divisible by 21. 42 divided by 21 is 2, and 63 divided by 21 is 3. Dealing with those variables, x to the 4th and x to the 3rd are both divisible by x cubed, and all that we have left is a single x in the numerator. Looking at the next problem, this is a little bit more difficult. We have binomials in the numerator, so we're going to have to FOIL that numerator. 8x times x is 8x squared. 8x times 4 is 32x. -32 times x is -32x. And -32 times 4 is -128 in the numerator. In the denominator, I am not going to FOIL it. I'm going to leave it as a pair of binomials there. The quantity x minus 4 times the quantity x plus 7. Because sometimes when we simplify the numerator, we can then just factor something from the bottom and cancel those out. In the numerator there, we're going to have 8x squared. And then this positive 32x and negative 32x, those make 0. And then we have minus 128. All of that is going to be over the quantity x minus 4 times the quantity x plus 7. That's how we're going to multiply rational expressions. It's a lot like multiplying rational numbers, just mixed with multiplying rational expressions, binomials often it seems. You may remember that when we divide rational numbers, we don't have a way to divide fractions. So what we have to do is we have to convert the division to multiplication. But when we do that, it's important to remember that as the division changes to multiplication, the second fraction, we have to write its reciprocal. So that means that we flip that fraction upside down, and then we multiply across the numerator, which will give us 36, and across the denominator, which will give us 75. And both of those, 36 and 75, are both divisible by 3. 36 divided by 3 is 12. 75 divided by 3 is 25. And that then is written in lowest terms. Looking at our next example, we again write that first fraction as is, change the division to multiplication, and then we use the reciprocal of the second fraction. And so as we multiply that, multiplying across the numerators, we get 18. Multiplying across the denominators, a negative times a negative is a positive, and 7 times 14 is 98. 18 and 98 are both even numbers, so they're both divisible by 2. 18 divided by 2 is 9. 98 divided by 2 is 49. And that now is written in lowest terms. As we think about dividing fractions in general, we take the first fraction, it stays as is. We take the second fraction, we use its reciprocal, so it's going to be d over c. Then we multiply across the numerators, which will be a times d, and across the denominators, which will be b times c. And that is how we can think of dividing fractions in general. I'm running a little long here, so that means it's probably time for a dumb math joke. Did you hear about obtuse angles and why they're always so depressed? Yeah, it's because they're never right. So anyway, didn't say it was going to be funny. Here we go. When we are dividing rational expressions, we have to take the second fraction and write its reciprocal. So instead of 5x squared over 8x squared, we have 8x squared over 5x squared. Now, I could do this multiplication straight away. However, I think it's actually nice to do some of the getting rid of some of the terms when we can, like this x squared and that x squared. Those are going to make a 1, and we can get rid of that right away. And that's all I'm going to do right now. 8 times 16, that's going to equal 128 over 19x cubed times 5 is going to be 95x cubed. And that fraction appears to me to be written in lowest terms. And for our last one here, I am going to get rid of some of these terms right now. This x squared will cancel out with 2 of the x squareds on top, leaving an x squared. And here, this x is going to be gone, leaving just a single x on the top. And now I can rewrite my division as 9x squared over 6 times 3 over 13x. Now I can do that multiplication, and I will get 9x squared times 3 is 27x squared over 6 times 13x is going to be 78x. And there is one more x term that I can get rid of now there. And I will have 27x over 78. And there is a little bit more simplifying that I could have done. Those are both going to be divisible by 3. 27 divided by 3 is 9, and we still have the x. 78 divided by 3 is going to be 26. And now we are finished. Thanks for sticking with me through that long video.